I would start by installing the ezdxf library, and it's a pretty simple way. Just type in the terminal pip install ezdxf. It will install that library for you. In my case, because I already installed that library, you will not see the same results that will be shown in your machine, but eventually, after running that line, you will eventually get the library installed. Now I will move on to the drawing or the example that I'm going to use in this video, which will contain a number of entities, including lines, as you can see, circles for the door handle, and you can click properties and see all the entities there. You have 3 line entities, 1 circle, 16 arc, 22 polylines. So yeah, these are the entities that is stored inside this drawing, this example. So yeah, I will be using this example to demonstrate how you can use the ezdxf library and Python to talk to AutoCAD. And believe me, it's going to be an exciting journey. So let's dive in. So what I'll do right now is I'll save this drawing, save as, and select the type of the file as DXF file, and we'll save it in a place, called it Python AutoCAD samples. So I pasted the path and just to change the name, let's call it sample1, for example. DXF and save it. I choose the 2007 there because it's a pretty old version of DXF. It will work in a lot of the softwares, in a lot of the programs, because it's a bit old version, so it kind of really easier to handle, easier to be recognized by other softwares and even by Python. Now going to the Visual Studio Code, I will do some imports. So the first line I'm going to do is, to import the necessary libraries that I'm gonna be using throughout the code. So the first line is import sys. So sys here is a kind of library or a package that is used in Python for certain commands or certain functions. Okay, so let me just understand what that line is. So when I say import sys here, it's kind of a a group of commands, let's say, or features, or or functions that you will be using. Yes, you are correct. It is a library, which means it contains a lot of functions, features that you are able to use rather than creating the functions from scratch. You can be able to use all these predefined functions inside the package or the library sys. Okay, the second line, it will be import ezdxf, which is our main library, basically, and the video is about it. All right, for that line, I think it's pretty similar to the previous line, isn't it? So again, it's import a library, ezdxf, but I presume that it will contain different kind of functions. And because it got DXF in its name, probably it has some functions or features that can work with DXF files or AutoCAD. And yeah, you would guess that from the name. But yeah, it's a similar approach, isn't it? Yes, absolutely, it is. So it's again, this line is gonna install the ezdxf library with its functionality. Okay, so the next line, it will be defining the file, the DXF file that I just created, in order to make Python able to read it. So the first line is doc equal ezdxf.read file, and I will provide the path between the quotation there. So I'll go back to the file location and I'll copy the path. So right click and copy as path, and then go back to the code and paste it there. There is some discrepancy there in the quotation. It is kind of doubled, so I removed the duplication. I removed the duplication there. Now, okay, before we move on to the next step, let me ask a question. So, okay, so what I read in that line is there is read file. I assume that is kind of, reading something, and because you have that dot, it means that this function is inside the library ezdxf. So it's a special to that library. And the output of that function is going to be stored to the variable doc. And you need to define the path for that file in order to store it. Am I right in that? Well, yeah, absolutely. That, you're spot on. So you need just to provide the path, and it will be the content of that drawing basically will be stored in the doc variable, and it will allow us to use different functionalities and features in the doc variable, because it will be inheriting from the DXF file a lot of its features and functionality. So that's basically why we need this line. So what I'll try is to run this code and debug it, and to see if it's gonna make an error. I'm pretty sure it will, because the path is not matching what Python would expect to read. And you can see now the error, and basically I think it's because of the path, how I pasted the path there. So what I've done is just copy that and paste it to a chatgpt without mentioning even what is the problem, just pasting it and enter. And I'm pretty sure ChatGPT is smart enough, to know the problem and what I'm trying to do. So you can see from the answer, it understands this is a syntax error because I didn't do the path in the right format, and it provided me with a solution. So not one solution, but three. So you can use double backslashes, you can use row strings, you can use forward slashes. These are the how you can fix this error. I like the row strings method because it's just adding that R character before the path, and that's why I used it here. So you copy the path as it is and then just add R before the path. Now if I run the code, it should compile, it should read the file, but because I don't have any further commands, it doesn't do anything. So the first step, we've done it correctly now. So we are reading now the DXF file, the AutoCAD file inside Python. The next step is I'll be getting the model space inside that file, and that's why I created a variable called MSP equal doc, which is the previous variable dot. So I access more functionalities. Dot model space and close the brackets. Okay, wait a minute, please. Just to understand what is that line. So what I can see, there is doc. Okay, we understand what's doc from the previous line. So it reads the DXF file, and it's got a lot of functionality that works for that DXF file. Now, one of these attributes or functions, let's say, is a model space or calling the model space. And we know in AutoCAD, we know what does model space mean, because we have the layout and the model area where you draft the drawings. So basically, what I understand from this line, that you are accessing the model space inside the drawing, and you are storing this into a variable called MSP, like a model space abbreviation. So yeah, so okay, I understand now. So we first get into the file, the DXF file or the AutoCAD, and then secondly, we are accessing the model space where all the work is being done, like all the entities are stored. Yes, absolutely. So Next, I will iterate over the DXF entities inside that model space, just as a way of understanding what is the process that I'm gonna do. Is I'm thinking, let's demonstrate that we are asking about some information about the entities inside the drawing. For example, what layer it is stored on, what's the starting point, what's the end point, for example, for the lines. So that's what I'm trying to do here. So in order to do that in Python, you need to iterate over these entities inside the DXF file. So I'm going to show how this happens. First, I will define a function that would help me print the information that I want the Python inquire about, or show me or print out this information for me. So first I'll tell it what sort of information I need, what sort of information I want it to print for me. So that's why I'll do define a helper function, and I'll show how we can define a function in Python. So def print underscore entity brackets inside the brackets e and a colon. Okay, let me just 1 second. So def print underscore entity and e between brackets. Let's go through this a little bit in detail. So I would assume def here is maybe a abbreviation for define or something. Okay, so and what is coming next is maybe the because you are saying it's a helper function. It's the function name. So it's the name that you would use to call this function. So it's called the print entity, and I assume from the name you will be using this function to print something for you. And what's e inside the bracket there? Oh, it's basically the input. So, for example, if you do a function, any mathematical function, for example, you want to calculate an area of a rectangle. So you've got variables for that rectangle, like the width and the length, etc. These are inputs. You've got to use them in order to make that function work. And the same thing here, entity, or E, the abbreviation for entity is the input. So you've got to tell Python what entity you want the information about in order to print this information. Okay, then the next line is print and between quotation line on layer colon, and then percentile s and backslash n. And after you finish the quotation, you would need another percentile, so it gets you the value of e.dxf.layer, and close the bracket. Okay, hang on a minute. Now, print, I would guess this is something, to print. You want to print something on the screen. So it's a function used to print anything, to print text, for example. And I assume because you have some values between brackets, line on layer colon, this is a text that will be printed out. So whatever you write there, it's going to be printed out later. But you've got percentile s and backslash n, and it has different layer even in the line. You can see it's in the blue for the percentile s, and slash n is a different color as well. So yeah, it's really a bit confusing because you are using two percentile. So first you're using percentile inside the quotation, and there is another percentile outside, and you have that e.dxf.layer. So let me guess. So the first percentile, I would assume there is a link between the two percentiles, that's for sure. And you are trying to put the value of ezdxf layer somewhere in the text. So I would say the first percentile is like a placeholder, or maybe a position where you want to insert some sort of value inside the text, let's say. And then the value itself, it's going to be returned from the second percentile. So whatever comes after the second percentile, it is the value that you need to print out, which is in this case e.dxf.layer. So I assume, because we understand now E is entity, and we are accessing dxf.layer inside this entity, so it means we are asking for the layer name, maybe? Yes, I think you got it right there, because yeah, it's absolutely right. It's printing that text line on layer colon, and it will insert in the place of percentile s the value of the layer name. And how it got the value of the layer name, it came from e.dxf.layer, because you called upon it. You called it using this line. So yeah, basically you got it all right there. Okay, the second line is going to be print. Let's ask about the starting point, for example, of the line. So start point colon, and I need the percentile again in order to get this value, \n for a new line, and another percentile, and then the term that will return the start point, which is e.dxf.start. Okay, so I think this line probably pretty easy now, because we understood the first one. So it's calling the starting point, and you got a percentile s there, which will take the value of e.dxf.start. So is it gonna take the coordinates in this case? What does that, dxf.start is gonna return, let's say? Yes, absolutely. It's going to return the x, y, and z coordinates. We will see that when we run the code, how it's going to show that information. So the next line is print again, and end point. So let's ask about the end point of that line, percentile s \n, and then the value is going to be taken from dxf.end. So it will get that endpoint from the entity. Okay, yeah, thank you. You could carry on, because yeah, I think it's very easy to understand now, the third line, because it's pretty similar to the start and layer, but we are using just end there to indicate that we are asking about the endpoint. So yeah, it seems very easy. So yeah, please carry on. So the next step is to iterate now over all the entities inside the drawing. But remember, we are doing the work only for lines, so we need some sort of condition inside the loop or the iteration that we are doing to define the lines in particular. So when I'll create now the for loop. So for e in MSP, which means the entities inside the modular space that we defined before, and you don't forget the colon. So let me stop on that one, because a colon here is really important after the for loop. If you don't have it, it's gonna make a syntax error. This is how a loop is defined inside Python. So you've got to use colon after that line. So that's something important. Okay, yeah, before you carry on, please, yeah, so for e in MSP. So e, I assume here is a new variable, or is it the same as the old variable? And MSP, it's clear MSP is the variable that we defined before, which is the modular space, which makes us get access to the modular space of the drawing. But what e is there? E here is entity inside the modular space. So it's the same concept. So it's the entity inside the modular space. So it will take the value of each individual entity one by one. So we seen in the drawing, for example, we have 3 lines, we have a circle, we have some sort of arcs, and polylines. So it will go through them one by one. This is what that for loop is gonna do. So the e here presents the entity in the modular space, and it will take that value one by one. Now I will provide the lines underneath the for loop, and in order for me to get the line, so I need a condition here, if condition, in order to be able to identify the lines from the different entities. So the line is fe.dxf type equal line. And then again, remember, you have to use the colon after that. Okay, so this line, I assume, because it starts with if, it's a condition. So we are saying if, basically we are saying if the entity type is line, do the following. And we will supply probably the commands afterward. But yeah, so that's the use of the if function, or the if statement there. Yes, absolutely. So what I'll do now is to use the print entity function, because we already created that function for this purpose. So what it's going to do right now is to go over every entity in the model space, and if the type of the entity is line, it's going to apply print entity function. So it will print for us the layer name, the start point, the end point. So look how simple it is. So it's a pretty concise, simple code in order to inquire about some information about the entities inside the DXF file. But something really good to notice here is the indent spaces that we use. So it's really important. So for example, when we define the function print entity, we use a little bit of a space afterward, so we can make Python understand these lines are inside the function. It's defined inside the function. Otherwise, you will get a syntax error again. So you've got to do that indent space before the print statements there. The same thing applies for the for loop. So before if, we provided that space again to make it understand that this condition is inside the loop. It's gonna be applied inside the for loop. Yeah, so I think that's all. Now we probably could just run the code and see if it's gonna work. I'm pretty sure it's gonna compile, because I can't see any red underline, because one of the advantages for Visual Studio is if you have an error or something, it will indicate that while you are writing the code. But yeah, let's run the code and see. And yeah, here we go. We can see the line on layer 0, start point. This is the start point XYZ, the end point XYZ, and the second line. This is the layer for the second line, and again the same information, start end. The third line, start end, and yeah, that's basically the output. We can go back to the drawing and just double check, see if our code is really working well. So if I just select all of them and get the properties, you will see we have only 3 lines in the drawing. So because we have that if statement, it makes us only deal with the lines, with the 3 lines only, to print the information. You could use quick select to select these lines and understand where are the location of these lines, and then we can even iterate on these lines and check the X or Y, Z for the start and for the end, and see if that information is accurate. So I've done that, and it's pretty accurate, basically, because it's reading the same thing, isn't it? So yeah, it's done, and actually you can run the code while the AutoCAD is off, like it's not open. You don't have to open the AutoCAD in order to get this information. All this geometric information you can just generate it while the file is off. So this is pretty powerful when you get more complicated codes and try to use these information to manipulate the drawing. and we will be covering these later on in other videos.